Integration of even powers of sinusoidal functions. I am Anil Kumar. Welcome to my YouTube channel and the website Global Math Institute. In this video, we'll consider four examples which are related with even powers of sinusoidal functions. Now, even powers are slightly trickier to work with. We'll see how to modify or write an equivalent expression using trigonometric identities and then find the integral. In case you want to learn directly from me, feel free to send an email to globalmathinstitute@gmail.com. Let me also thank our viewers and subscribers for watching our videos, posting excellent comments. I'm very grateful to all of you who are also contributing. Each dollar counts. We are able to reach millions globally to those who cannot afford quality education. So, once again, thanks a lot for your support and contributions. Now, let's watch the solution of this particular question. Now, let's try to understand how do we integrate these functions. Well, we know the integral of sine x cosine x or sine ax plus b, right? Whenever the powers are there, we need to simplify them first. And especially when we have even powers, then we follow a particular strategy. And that comes from the fact that cos of 2x, as you know, is equal to cos square x minus sine square x. And it can also be written as 2 cos square x minus 1 or 1 minus 2 sine square x. Now, this particular formula of double angle for cosine helps us to write the squares and even powers as in the form of angles, right? So now you can see that we can write cos 2x cos square x as what? Using this particular portion, which is cos 2x is 2 cos square x minus 1, I can always write 2 cos square x as equal to 1 plus cos 2x. So with that, we convert square into double angle, right? Similarly, we could also write what? 2 sine square x is, right? So 2 sine square x is equal to 1 minus cos 2x. So that helps us to rewrite these expressions as double angle, right? And then find the integral. So that is the concept which we are going to use in this particular video. So let's begin with the very first question, which is sine square x dx. So as I said, we know that cos 2x is equal to 1 minus 2 sine square x, and so we know that sine square x is equal to, let me write 2 times first, is equal to 1 minus cos 2x, correct? Rearranging. Or we can say that sine square x is equal to half of this, right? Half of 1 minus cos 2x. So that is how we can actually write sine square x. So this is what we are going to use for integration. So now let's look into the question given to us. We need to find integral of sine square x dx. So that should be equal to substituting sine square x as half of 1 minus cos 2x, correct? Dx. So we can take half outside. Integral of 1 plus 1 minus cos 2x dx, and that gives you half time integral of 1, which is x, and minus cos 2x. So cos 2x integral is sine 2x. So that gives us minus sine 2x and divided by 2. Makes sense, right? And plus c, of course. So now we can open this bracket and write down the answer as x over 2 minus sine 2x over 4 plus the constant c. You see how we have done this integration, right? So the idea here is to use this part of the formula and rewrite the expression with cos 2x, right? So I hope the integral of sine square x is absolutely clear. Now let's take up the next question, which is we need to now find integral of cos square x sine square x dx. Now to find this integral, we need to simplify this. Let's recall that what is sine of 2x equals to? Well, sine of 2x is 2 sine x cos x. Perfect. So that can help us to find out a simplified form of this integral, right? So you can also write this as sine 2x, half of this is equal to sine x cos x. Correct? So we are going to use this trigonometric identity to simplify the integral. So now let's look into the integral, which is integral of cos square x sine square x dx. We can write this as equal to cos x sine x whole square dx, right? Now cos x sine x is equal to sine 2x over 2, right? And whole square dx. Perfect. So this can be written as equal to integral of 1 by 4 sine square 2x dx. Now we know what is sine square x is equal to, right? So that is equal to half of 1 minus cos 2x, right? So this could be written as equal to 1/4 times, this is half of 1 minus cos 2x, double of this, right? So cos 4x dx. Does make sense? See, we have written it in the form of double angle or 4 times the angle. And now it becomes easier for us to find the integral, right? So we have 1 over 8 times 1 minus cos 4x dx. Let's take it to the next page, right? So we can see that we can write this integral as 1 over 8 times 1 minus cos 4x 1 minus cos 4x dx. So this integral will be 1 over 8. Integral of 1 is x minus sine of 4x divided by 4, correct? Plus c. And that gives us the answer x by 8 minus sine of 4x by 8 times 4, 32 plus c. Perfect. So that is the answer which we are going to get for this part, correct? So I hope the concept is absolutely clear, right? Let's move on and take the next question, which is we need to now find integral of cos to the power of 4x. So let's simplify first cos to the power of 4x, right? So that is a better strategy. Cos to the power of 4x is like cos square x whole square And we know what is cos square x. Cos square x is half of 1 plus cos 2x whole square, correct? And this can be written as equal to 1 plus 2ab, which is 2 times cos 2x plus cos square 2x, right? Over 2 square is 4, correct? Now, once again, we have here cos square 2x. So that square term should be written into the form of cos 4x. Perfect. So this can be written as 1 plus 2 cos 2x. We can write them as 1 over 4 and cos 2x over 4 plus 1/4 of cos square 2x, right? So when you rearrange cos square 2x, we again get 1 plus cos of 4x over 2, right? So that is what you get. So that becomes equivalent expression for cos to the power of 4x, right? So 1/4 of this, right? So we'll just take it on the next page and then find the integral. So we have here integral of cos to the power of 4x dx as equal to integral of 1/4 plus 2 cos 2x, we could simplify that, plus 1/8, right? Plus cos 4x over 8 dx. Correct? So that is what we get. And we can now simplify it, write down the integral 1/4 of x, right? So it is x over 4 plus, so when you divide this by 2, so cos 2x will give us sin 2x. Divide by 2, that 2 cancels, we are left with 4. And here we have x by 8. And then we have cos 4x is sin 4x. Divide by 4 gives us 32 plus c. Do you see how easily we have found this integral? Now you can add x by 4 and x by 8, right? You can combine these two terms. We could have done it earlier also and rewrite your answer. So if you take 8 common, so you get 2 plus 1, 3. So 3x by 8 plus sin 2x by 4 plus sin 4x by 32 plus c. Make sense? So with that, we have solved and found the integral of cos to the power of 4x dx. Absolutely clear? The last one here is the combination of what we had done before, right? So now we have integral of sine square x cos 4x. I would like you to take this as a test question, solve it, and then check with my solution in the next video. I hope it makes sense. Feel free to write your comments and share your views. If you like and subscribe to my channel, that'd be great. Keep supporting. This is your channel. With your help, we can reach millions. Thanks for your time and all the best.